It's okay. It's okay. It's okay. I think it's okay, you know. So are we good to go, Enoch? Because we are 2 minutes past the time.
Okay. Okay. I was
so
we had 1 hour. Like
yes, we have 1 hour for this session. So
okay.
we have an intro of 15 minutes. So between now and 15, we should be doing the intro. So
Okay.
let's say that we open the room and then we let play the music so that people can join.
Okay.
Rebecca was saying the microphone tests. Okay, you can, and yes, you can message Enoch, but I will have an eye on the chat also if anything needs. Okay, c'est bon. Okay. So Enoch, I think we are good to go for the music.
Okay.
Well, let's say we play the music from 3 to 5 for 2 minutes. Is it enough?
It's about 5 minutes. Then once the music stops, I will stop share and you continue with the holding slide.
Okay, let's go for that.
Good.
Good. Can open the room.
Afro. Recording in progress.
Bonjour à tous. Bonjour.
Hello, everyone. Welcome to the Central African Peering Forum. My name is Ghislain N, and I work with the Internet Society, and we have the pleasure today to welcome you in this fifth forum. Fifth edition already, 5 years that we have been organizing these forums, and we're glad to welcome you to this year's edition over 2 days. And to this effect, I would like to invite Sylvain B, one of the co-presidents of the CAPF and the steering committee, to introduce himself and give us an overview of today's program. Sylvain, you have the floor. I think you need to turn your microphone on. Thank you, Ghislain, for this introduction. Welcome to this fifth edition of the CAPF Forum, the Central African Peering Forum. So to tell you a brief story, 2 routers were trying to connect, 2 different ones tried to connect, and one of them thought that they were supposed to take an intermediary to be able to connect and be in contact with the rest of the world. The second one had the same idea. They were isolated and they didn't work together. They didn't discuss. It was a beautiful idea. They managed to connect with the rest of the world, and they then discovered that they were close to each other in the same sub-region in Central Africa. And the Central African region, so this same region that they're both in, these 2 routers then thought, well, why do we need to use these intermediaries to be able to exchange traffic, communicate amongst ourselves? And that's when they had the idea to create this forum where you are all very welcome. Thank you very much to the Internet Society, who supports us, who supports the steering committee for the CAPF. Thank you also to the CMAC, who also provides us with support. Thank you to each and every one of you for being here. Today is
la première journée. Nous avons au programme déjà un keynote qui devrait être présenté. Ghislain, je n'ai pas j'ai pas le programme avec moi là.
Ghislain, I don't believe I've got the program with me. So Nico will be the first speaker today. I see a few members of the steering committee present with us today. I think Landry is with us. Chancel, our co-president with me, and others possibly, but I'm sure you will get to meet them virtually throughout these 2 days. As Ghislain said, I think, Ghislain, maybe you will be giving us a brief introduction? Conditions, have you done that? No, I've not done that yet. If you could do that, I don't think I have the document with me. Okie doke. Enoch, would you be able to show the holding slides, please?
Ok. Alors, rapidement.
Okay.
Si vous permettez, je vais juste lancer
I'm just
les slides.
going to show you my slides.
Donc, aujourd'hui, nous
So
avons
today,
le co-chair qui est là.
we have one of our co-chairs with us, Monsieur Sylvain,
Le deuxième
and
co-président, la deuxième
the
co-présidente, c'est
second co-president is Chancel Barra,
la RPCE au niveau du Congo.
based in Congo. The objectives of our forum are to promote the development of the internet ecosystem, to have a robust and sustainable ecosystem in the Central African region, to encourage local interconnection and peering between ISPs and CPs. We also want to provide a platform for sharing of knowledge, to strengthen capacities and networks. And it's also a place where we can share best practices in terms of internet interconnection, peering amongst the different regions and their relation with Central Africa. It's also a platform where you can do some advocacy for political reforms or new regulations. So for this session, I think Sylvain will be our moderator. Our first speaker will be Nico Chintu, who is the executive secretary of Kinix, Gomix, and Lubix in Congo. So in terms of a couple engagement rules for this session is recorded, so it is important for you to follow and share the event, the information after the end of the forum. I want you to engage in respect and be responsible. Please ask questions and as brief, direct, and simple as possible. You can phrase your questions by telling us who you are, so your name and your country. So you can see a couple examples here on the screen, Emily, Ethiopia, or Jacinta, Uganda. Please give us your name, your country, and then type out your question. And finally, we would encourage you to familiarize yourself with the Internet Society's Code of Conduct, and the link is on the screen now. So we have two hashtags that we are using, FPAC 2024 and CAPF 2024. This is a forum, so the forum, the Central African Peering Forum. Our session has interpretation into English and French. We're very happy to be able to have excellent interpreters with us today. They will be interpreting the sessions into French and English. Just please choose the language that you prefer and you will be able to listen to the event in that language. There's also a chat room where you can post comments, questions, should, however, be posted in the Q&A function. So please keep the discussion room for discussions, comments, but if you have questions, please post them in the Q&A section. So for our first day today, we will start with a keynote speech. We have Monsieur Nico. Monsieur Guichard will actually be doing tomorrow's keynote speech. We will then have a session on general aspects, value, and benefits of peering with Monsieur Sylvain. We will then have a 1-hour break. So these are the Central African times. After the break, we will move on to technical aspects, and we can have discussions around different technical issues. If you have specific questions to specific sessions, please ask these questions to our technical experts in our third session of the day. And finally, we will end towards around 4 o'clock with a small speech, a few words from our co-presidents. And with that, I will now give the floor to Sylvain, who will invite Nico to give us an opening for the first session. Thank you, Ghislain. Nico, are you with us? Yes, I am present. Fantastic. Thank you very much. Nico, I will let you introduce yourself, and then you can introduce and you can start your keynote presentation. Fantastic. Thank you very much, Sylvain. I should be sharing my screen right now, if you can see it. Yes, we can see it. As Ghislain said, I am Nico Chintu. I'm in charge of IXP operations in RDCI. So that's 3 IXPs. The one in Kinshasa called Kinex, the one in Lumbashi at the south of the country. Lubix is what its name, and one in Goma, a city in the east of the country, and that's the IXP called Gomex. Today, I'm going to try and share with the community and tell you about what has been done in terms of peering in Central Africa. Before starting, I wanted to tell you a little bit more about why the Central African region. It is a region situated mostly in Central Africa, as you can see on the map here. It covers 6.6 million square kilometers and has a population of roughly 175 million inhabitants in 11 different countries: Angola, Burundi, Cameroon, Gabon, Guinea, Equatorial Guinea. Apologies, it seems to have shown up as 2 different lines in my slide. The Central African Republic, Republic of Congo, Democratic Republic of Congo, Rwanda, Sao Tome and Principe, and Chad. And before we start discussing peering, I first wanted to give you a few simple definitions to make sure you understand what peering is and what its advantages are. Where do you do peering? Who does peering? So for us, peering is an agreement between 2 or more internet service providers, local ones, who interconnect themselves through IP networks so that they can exchange freely traffic via an IXP, an Internet Exchange Point. So an Internet Exchange Point is defined as a physical emplacement that is generally neutral, where at least 3 IP networks are connected or meet up to be able to exchange traffic via a switch. So moreover, why do peering? What is the advantage of peering through this IXP? Well, first of all, the first advantage is to keep local traffic local, preventing local exchanges to go through other foreign countries and then come back to the region. With an IXP, we can keep local traffic at a local scale. And this saves on bandwidth. This provides the ISPs and content providers to reach final users more easily, and allows these final users to be able to access a quality service, especially when it comes to apps, content, and other software and services that can be sold online. This, as I already said, will also allow us to save on international bandwidth. So who can connect? Well, traditionally, at the start of the story of peering, you would have had these ISPs, these internet service providers. But on top of these, you would also have content delivery networks, providers of content and internet services. We've got companies who sell services, internet services, such as Google, Facebook, Microsoft, public administrations, and other organizations who may sell or produce services online for the general public. Now that we've covered those bases, I wanted to show you the interaction between the various stakeholders, the various players in the internet ecosystem. We drew inspiration from various diagrams. This picture from PCH we thought was quite useful to show how the various players in the internet ecosystem interact so that everything functions properly. In the internet ecosystem, if you are alone, things won't work. You need other players' support. An IXP, for example, can only work if operators are connected. And these operators are ISPs. The ISPs connect to be able to provide services to their customers, and these customers need to be able to use these internet services. And following that, the services used need to be stored in data centers. So in short, in this ecosystem, we can clearly say that all the stakeholders are spread all over in terms of infrastructure of internet transport. They are also queued into infrastructures for the IXP, infrastructure for content hosting, and service producers. Here, I wanted to give you a brief overview of what happens online. But in a peering ecosystem, we have the central point, the IXP, and this IXP generally would have direct collaborators, the ISPs. Behind the ISPs, you have the CDNs who also then need data centers to be able to function. And behind the ISPs, you also have the content and service providers who need to use the ISPs to make products available on the IXP. And as I said, behind the ISPs, we also have consumers or end users who will be using the ISPs to take advantage or consume the products that are available on this common market that we call the exchange point. Further out, behind the ISPs, behind the data centers, we also have the transporters or sellers of transit. All these stakeholders, all these players, find themselves in an environment that we have dubbed the peering ecosystem. Now, let's see what this looks like in reality. You've got this core, the IXP, at the heart of peering, but let's see how many IXPs have been registered in Central Africa. In total, we have 14 IXPs for 11 countries in Central Africa. And here you can see them per country. In Angola, there were 2 exchange points, or IXPs. I tend to swap between the terminology in French and English. Gabon has 1. Congo, Republic of Congo has 1 IXP. Cameroon has 3. 2 CAMEX and 1 Douala X. Burundi has 1. Rwanda has 1. Equatorial Guinea has none. We don't have any information. Central African Republic does not have an IXP. Chad has 1 IXP. But we do not seem to have much information about Chad IXP. It's something I will discuss further later on. Sao Tome and Principe does not have an IXP, and our DRC has 4 IXPs, 3 managed by ISPA DRC, and another one managed by a company that is relatively local called Untitled. And as I said earlier, we have very little information on IXPs in Central Africa. And this information is, or lack of information, is linked to a lack of communication in Central Africa. And so even the information that we share with you was difficult to collect, in the sense that you will see some of the information is published on the different platforms, be they websites for operators or DB peering database, but all the information doesn't match up. And we face certain difficulties when we then want to publish information that is accurate on what is going on in Central Africa. However, we have tried our best to present this information, and this is what we have produced. So 36% of IXPs IXPs that are operational in Central Africa do not have an online website. To get information is really difficult because you have to call, you have to use personal contacts. And even those who have, 22% of IXPs don't show statistics or don't publish statistics on their websites. So 22% of IXPs who do have an online website don't publish statistical information. And for those who do have a website, over 70% do not update it and do not publish up-to-date information, which prevents us from having accurate data and information on the Central African peering ecosystem. We have, however, done our best to be able to give you a good idea of what is going on in Central Africa.
So looking at all the IXP in Central Africa, we looked at what network are connected. So either for ISPs or transit sellers or content providers or service providers, but how many networks are actually exchanging traffic in the IXP in Central Africa. Here we can look by country. So in Angola, there are some IXPs. So the first one is Angonex, and there are 21 peers on this IXP. I think that's the biggest one in Central Africa. Angola IXP has 14. In Gabon, there are 3 peers exchanging traffic. In Congo, Brazzaville, there are 9 peers. In Cameroon, in Camex in Yaoundé, there are 9 of them. In the Camex in Douala, there are 7. In the Douala IX, there are 7 as well. In Burundi, there are 10 peers that are connected. In Rwanda, there are 13 of them. In Chad, we have no information at all on how many peers, how many networks are connected. In Sao Tome and Principe, there are none. In clinics in DCR, which is dealt with by the Association of IXPs in DCR, there are 20. In Lubix, there are 11. Comex, there are 10. And Agar has 10. No, Comex has 10. And also, there's ASICs, and there are 4 peers on this one. Now, we also tried to look at the ASNs for Central Africa from the CDR, that's why I'm mentioning all the time, but we are looking at all of Central Africa, and we looked per country and to see whether those ASN contribute to give dynamic ecosystem of peering. And we've noticed in Angola, for instance, that on all the ASNs allocated to Angola, there is not more than 50% of ASN that are connected to the IXP. And the similar situation is happening in Gabon. Also in Republic of Congo, same situation. In sorry, I'm making a mistake. Republic of Congo is different. There's more than 50% of ASN that are connected to the IXP, but the situation is no in Cameroon, yes in Burundi, no in Rwanda, and no in Democratic Republic of Congo. So when you want to look at the evolution of peering in Africa, we want to see who is exchanging. Are our IPX, IXP viable? Are they bringing other networks in, ASN that are allocated to other countries? Well, we've noticed positively that in Angola, there are more networks or peers that are coming from outside and are connecting to the Angola IXP, to Angonix 76%, and for Angola IXP 57%. But in Gabon, it's 14%, and in Brazzaville, Congo, it's 22%, in Cameroon, it's 20%, Burundi, 40%, and in Rwanda, 42%. And in DCR, we have Kinex at 36%, Lubix at 27%, Gomix 20%, and ASICs at 25%. And we also thought, because among the different major actors of the ecosystem, there is the data centers. And do we have enough in the region? So we noticed that in Angola, there are 3 data centers. So with this infrastructure, a lot of operators coming from outside of the country come in because there are the local infrastructures needed. But in Burundi, we don't have any information on this. In Republic of Congo, we don't have information. I've been heard that there is one than more data center, that there's collocation, but I don't know. Cameroon, maybe one. Gabon, there's none. In Rwanda, maybe more than one is doing collocation. And in DCR, there's more than two. But even with the ones we have, we don't have specificity. Sometimes are not certified. And two are being built, and they are very welcomed. But at least with this information that we managed to collect, we've got enough view, and we can see that in terms of content and data centers, we need to really work on that because and improve things, because it's not bringing content providers or ISPs to come into Central Africa. I mean, there's an exception that we can make for Angola, let's be honest. Now, you can look at that map. It's here to illustrate the other downside of Central Africa is transport, digital internet providers, internet networks on the ground. This map is not very far from reality, which means that Central African countries are not enough. There's not enough interconnection between them. So if you are in Democratic Republic of Congo, in Kinshasa, for instance, it will be very hard to reach Kimberley. By optical fiber, terrestrial optical fiber. Again, it's hard to reach Central African Republic as well, or to reach to Chad. But it will be, but for between the Democratic Republic of Congo and the Republic of Congo, there is an interconnection. It's easy. And there is also one with Central African Republic. Well, I think they had a project. I don't know where that project is, but we've not heard much back, so I don't know where they are at, those projects. We can feel that the policy of the trans-border digital transport is not something that is pregnant and important in Central Africa. And there is a clear lack of infrastructure in this area. It's obvious when you look at the map. And in all, we've mentioned about what's happening in Central Africa. We can think of how do different stakeholders interact to develop peering. So I'll overlook this a bit because you know that the world goes in at two different speeds. There are different ecosystems we are in some ecosystems in developed countries. Sorry about the way I say that, but you have all the infrastructures for digital transportation, and you have also everything in terms of production of services and content, digital content. You have high demand in access to internet and content services and digital application. In this kind of context, the creation of IXP is a good way to help with access to content and developing peering. And the IXP will play its traditional role that we've presented up till now. But in an environment of with stakeholders less developed, I'm sorry to mention it in those terms, but it's an ecosystem where there's low presence of digital transport infrastructures. There's hardly any presence of digital collocation, very low production of services and digital content, very low demand on the market for access to internet, content services, and digital application. In such an environment, of course, the IXP will play its traditional role, but it won't necessarily become mature very fast because its functionality will be a problem. And the IXP, as a stakeholder within that ecosystem, will be called to play a different role, because it will be there to try and boost the other stakeholders to really help develop this ecosystem overall. And this is what's happening in Central Africa. And all the data I've shown you, and we managed to collect, we can see that IXP in Central Africa needs to play a different role than the traditional role, which, what do I mean? Well, they need to be implicated in trying to find solution to issues that we can see in the community. They need to lobby for the development of infrastructures for digital transport. They need to lobby for the development of infrastructures for data centers and digital collocation. They need to promote the production of services and digital content locally, and they need to implement communication strategies based on the attraction for other obstacles of peering towards a more local peering ecosystem. And there is another stakeholder that is really important, is the final consumer. Is the final consumer in Central Africa enough aware and know enough how to use internet? So these are things that the IXPs need to work on to try and find solutions and allow themselves to really play the role that they are here for, you know, and overall improve the quality of internet in those countries. Among everything we've collected and what information we could get, we can come to the conclusion that there are a few challenges that we need to overcome. So we need to encourage ECCAS countries that don't have IXP to at least build one, encourage the connection to more local OSNs, to more IXP, local IXP to local ASNs, produce and have data centers for local content and at higher level as well. Promote the construction of data centers, infrastructures for content, promote the usage of internet as a mean of work, give the ECAS countries some land infrastructures for digital and for internet. So this is what we wanted to share with you on the reality of a peering ecosystem in Central Africa. Thank you very much. Thank you very much, Nico, for this great presentation. You've allowed us to see the internet ecosystem in Central Africa, and it was very good for us to know that. I have noted that you've mentioned some difficulties and the sub-region, and those difficulties are reducing the local traffic within the sub-region. And you've mentioned the fact that there is no public data, no publication of data on traffic. It would be good to be able to see what's happening and the other things that are not up to date. This is something that is surprising for us to see that the websites are not up to date. It's good to know. You are also mentioning the providers and of internet in Central Africa that are an issue. And there's the question of productivity as well, locally. And you noticed as well, the local, producing local content is something that is complicated. Very often services are outside the country, like inboxes, for instance. And you've also noted in your statistic that some countries don't have any IXP, like Sao Tome, for instance, or others. And you've mentioned as well to try and see that all those IXP are profitable, because so that all the so that the local traffic can be maintained. Thank you very much. That's what I could say to summarize what you've said. Now, I will take questions if there are some. If someone have questions, they can put it in the question and answer in the Q&A part at the bottom. Do we have questions? We can also take questions from the panelists. There are already 2 questions, Sylvain. Sylvain, there are 2 questions. Can you read them out, Ghislain, please? Moussa Stephen is asking, what strategy to attract more providers in IXPs? We noticed that our IXPs are just empty. And then he asked a second question in Cameroon, why do you count CAMEX as 2 different IXPs? I can answer the questions from Moussa. Maybe there might be more later on. So the strategy here to attract more contractors is the communication policy of IXPs managers. When there are forums, when there are people meeting, we tell IXP managers to go and present the viability of their IXP and also work so that IXP be attractive. You know, how can we make it attractive? Well, we need to provide added value. So it's like you go to a market when you will find the product you want. So if I am an IXP, you need to look at the community, try to understand what it wants, and try to meet those needs, you know, offer those products in their IXP. And then the different stakeholders are going to come in. So there are potential, but we need to maintain this potential. So that's why we talked about the final user as well, because we need to train them so that they can use internet more. I don't know if the managers of IXPs agree with me on that, but that's my vision of things. And you shouldn't forget as well that there are other operators that should come in as well, so that they can bring in content to Central Africa. And to answer the second question as to why is CAMEX counted as 2 IXPs, there are 2 IXPs, one in Douala and one in Yaoundé. There are 2 different points. They have 2 ASNs. If it was the same ISN, we would consider it as one. But because they have two ASNs, they are two different IXPs. That's how we count two, because of the ISN. I think I have responded those two questions. Thank you very much. Are there any more questions? Maybe we could add that it's also in two different cities. So Amex is based in two different cities, so it's two different points. Thank you very much. Thank you for explaining this. Yes, indeed, because the IXPs are local, they allow us to open an area, like an economic area, maybe we can call it that way, or a city. It's to exchange traffic locally. If there are operators that are in Douala, maybe they're not in Yaoundé. So it's really to provide local traffic. Thank you very much. Do we have any more questions? Yes, Ghislain, your hand is up. Go on. Yes, I wanted to suggest to Nico, if that's possible, if maybe we can compare to last year, because I think we had extremely similar data, like statistics. So if we could look at 2024 to see if there is an increase or a decrease, to have a more progressive view or on a long, a wider view on things, I think that would be useful. I'm up for it. Ghislain, I'm happy to do that, because indeed the data that from last year or from the previous years, I think there are some evolution. In some countries there has been an increase, in others there's been a decrease. We've noticed an increase in Angola, in DCR as well, also in Rwanda. But we've also noticed in other countries that things didn't go that well, like in Gabon, for instance. There is an IXP there, and it didn't go forward. There are different realities like this, indeed. So we'll take that into consideration. Thank you. Thank you very much. That will allow us to maintain the availability of the statistics. Thank you for suggesting this, Ghislain. Do we have more questions? Do we have more time? It's 11:56 in Cameroon. We still have 15 minutes. Do we have more questions? Does anybody see a solution for our two routers? After that presentation, quite interesting presentation of the ecosystem of peering and internet in Central Africa. There are no questions, I think. There is a comment still from Musa, who says, thank you, brilliant presentation. It really showed the technical level that is quite high in Central Africa. However, when we're talking about IXPs, they just can't really implement good practice. Even when we suggest recommendation, even on basic things like a direct line, things are still complicated. Why do you think this is not reached? We don't have basic provisions. Well, there are different reasons for that. First of all is financing of those IXPs. And this creates issues because the most people managing IXPs are volunteers. They don't have enough means to maintain those IXPs. They just can't do it, because to maintain a website, you need time, you need dedication. And in those IXPs, you will find one person that is here to conceive it. Then it's the same person that does orientation and execution. It's just the same person to do everything, because they don't have any money to get any other person in. So how can that work? It's impossible. The issue here is money, clearly. Thank you very much, Nico. You are mentioning something that is really interesting, and everybody is listening to that, and they can see what are the challenges. So thanks for mentioning that, and thanks to Musa for raising this, because this is a very important topic. Volunteering, yes, of course, we have volunteers, you know, the CAFP steering committee is made of volunteers. So of course we've got volunteers, but if we don't help them, it's going to be an issue. So do we have any questions? If not, we might conclude. Do I have comments or questions? It doesn't look like it. We don't have any question or comment. So we can close the session then. It's 12 o'clock in where I am, so we will close the session for now. Thank you very much, Nico, for that presentation. I don't know if you want to give us a last word before we're finished. Thank you for your participation and for your presentation. Do you have one last word? So far, no. I'm open to any questions from the community. If you want any information, any piece of information, just get in touch with me. I'll be happy to answer. And to try and help us go forward, what can you tell us? For all the volunteers you've mentioned before, for volunteers, I understand what they go through. I understand it's not simple. I'm encouraging them indeed, but I also ask the rest of the community to help them, because I'm not against the community. I work for the community. But when everything works, the community applauds, you know, but when it doesn't work, they just like pointing fingers. So it's easy to point fingers, but it's also good to try and help people to do things. And so I'm really thanking the volunteers. They're doing great work, and I'm ask for the rest of the community to carry on supporting them. I think what you've said is not heard only by the Internet Society. It's a foundation that has a bit of funds, so maybe this is something that is worth saying. Thank you to the Internet Society for that. So I think we will share the link for this session, and now I will close the session. Thank you very much. Ghislain, the floor is yours. Thank you, Sylvain. Thank you, Nico, for this information that is quite on the point. I think we can remember that there is quite a lot that needs to be done, even for countries that don't have IXPs. And I'm looking at that list that you've shared with us, Nico. And there are some countries that have done 2 or 3 years, and if they are that don't have IXPs, if there are people in those countries that are hearing us, you can reach out to Nico or to other Cameroon community. I think there are some things that are in place in some countries, and we know a bit of how to run those IXPs, and we've got expertise that we can share. That's what I'll remember from that session. So I think I will now give the floor to Landry for the next session. Thank you very much.
Landry, tu nous entends?
Oui, bonjour.
Landry, can you hear us? Yes, I can. Hello, everyone. Thank you, Ghislain, for giving me the floor. Hello, all. Hello, Nico. Hello, Sylvain. I'm Landry Ligombe. I'm in charge of the Gabon IXP. For this session, we will be discussing general aspects of IXPs, giving you an overview of value and benefits of peering, and we will also focus on some economic aspects. First of all, thank you very much for giving me the floor as moderator of this session. This session aims to focus on benefits of peering and importance of IXPs in Central Africa and analyze economic aspects of peering. During the session, we will have two speakers who have already started their participation for day one. Ghislain N, who's an expert in IXP development and is also a consultant with the Internet Society. He's an essential player in the African internet ecosystem, and he really supports via ISOC the African IXPs in our subregion in Central Africa, but also in other regions of Africa, such as Eastern Africa, Northern Africa, and all regions where there are IXPs. We will then have a second speaker, Sylvain B, who you've already heard from today. Sylvain is the co-president of the organizing committee for CAPF, the Central African Peering Forum. He is co-president with Chancel, who was mentioned in the introduction. These two speakers will discuss these topics, these themes that we mentioned, give you an overview of IXPs, general aspects, values, and benefits of peering, and also focus on economic aspects. I won't keep the floor too long. I will now going to give the floor to either one of them. Maybe we could start with Ghislain. Can you confirm you can hear me?
Oui, je t'entends bien.
Yes, I can hear you well.
D'accord. Merci. J'espère que vous pouvez...
Fantastic. I hope that you are seeing my screen. Yes, we can see.
D'accord, ok. Donc, merci beaucoup, Landry, pour
Thank you very much, Landry, for
l'opportunité de pouvoir
the opportunity to participate in this second session covering general aspects, economic element of peering. Again, today this is our second session, and so we will stay quite general, but these are things that we wanted to remind everyone of. And so my presentation today will touch upon connectivity, economic aspects, and costs, just so that we can understand what we mean by peering, that we've been talking about it for a while, but what are the economic implications? What's the difference between having an IXP, not having an IXP? What does that change? What does that not change? So first of all, we will be talking about private versus public peering, transit concepts, aspects that impact costs such as distance, IXPs, hosted caches, advantages and drawbacks, and the availability of local content. And then we will conclude and hopefully hear some recommendations from all of you. So we talk about private and public peering with two main meanings. When two networks, like Sylvain was saying, I've got an AES and I've got this network, or there's two networks or three, the two networks could do private peering. When there's three of them, they then need to maybe consider the creation of an IXP. We now speak of public ISP if it's included on an infrastructure that is a switch or a commutator. So with private peering, you've got direct connections, but when it starts being 4 or 5 of you, 20, 30, 40, 50, the direct connections don't really work. And the solution then becomes that IXP is the central, the core, the knot of all this traffic exchange. It is important to note that control of routing policy is still part of the network itself. The IXP does not influence the policies around exchanging traffic. If I decide to do peering with Landry, the control of what I'm saying and that you're filtering and what you're saying and what I'm filtering stays in the hands of the network. Whereas with the AXP, there is no influence on the routing policy in general. It's also important to establish a relation. So what do I mean by transit? Here you've got A, B, and C. A is the network. C isn't connected to A. C'est a typical case in the case of maybe just one network in DRC connecting to an European network via B, and then it gets sent back to a country in Central Africa, and that's A. So that's the concept of transit. It's a commercial relationship most often. And it means that between A and C, there is a third an intermediary. It is a metered service. Depending on the volume that you're sending or the quantity, you have transit because you have to use this intermediary. I think they're two very important concepts: peering, public or private, and transit, because transit is very much a commercial relationship. So here, for example, you can see traffic goes between A and C via B. It goes both ways. B collects funds from A and from C, so it collects twice the amount. So money goes up. When there's transit, if there's no local peering, the funds, the money, leaves the country. So if there's no peering between A and C are giving money to B, and B is the one becoming richer. It's the same concept if in one country there's no exchange point and all the traffic go to another country, then the original X country is financing the economy of the other country. It's also important to mention that costs are linked to two elements: speed and distance. The more you need a faster speed, so for example, today you may be consuming 1 gigabyte, but tomorrow maybe you may be consuming 10. So the faster speed you want, the more you have to pay. But it's also important to note this question of distance. The longer the cables, or the higher the cost. Because if between A and B, let's say A and C, if you can't just go through B, but then have to go through B, D, E, F, G, and such, There's layers and layers and layers. And that will have an impact on the final user. For me, this equation is very important, and it helps us understand the importance of peering. Speed, distance are directly implied, like have a role to play in an increase or decrease of the cost of the internet. We've got other aspects that impact costs. There's economic implications. So as you can see, you've got different IXPs connected to D and E, connected to other countries. A, B, and C don't have an exchange point. So what we were saying, that A, B, and C are financing D and E's economy, or the country of where D, E, and E are. But that's important because D and E have an IXP. There are two types of traffic also. There's blue traffic, local traffic. Apologies. Green and red are the local traffic. Blue is transit. So in D and E's case, it goes to D and E or keeps going to other countries. So the C cost can change based on distance, for example. Which country are D and E in? The red arrow is pointing to loss of capital. A, B, and C are paying money, funds, just like every other international transaction. They would be using various currencies. It's money that is leaving the country. And A, B, and C have clients paying in local money. So there then needs to be a conversion made to then be able to pay. So it's like an exchange office for a currency exchange point. You need more local funds so that you can then pay the providers and so on and so forth. You want to avoid loss of capital. So what do we need to do now? Well, what do we need to reduce costs? We can't reduce speed because speed is important and we've got more consumption, we've got social media at the moment, then we'd have 5G, 4K, there's more traffic that requires faster speeds. So here in the equation, what we can change is by focusing on this distance element. So they created an IXP, and by creating an internet exchange point, all the traffic at the local area stays locally and does not use the transit connections. Costs are still relatively high, but that solves, at least partially solves, the problem. Things stay at the local level. There's a reduction of costs for the transit. There's an improvement in the experience of customer through the capacities for peering, and an improvement of security with the reduction of transitory networks. So what's the next step? Well, you would then need to be able to take into account these network caches. They try and localize traffic. So there are caches and C, and they would then help prevent overuse of transit. So here, A and C are the first beneficiaries of the caches. If they want B to be able to reap the benefits, they would then have to draft specific agreements with a cost. So international content are hosted locally. I'd say that's positive because it leads to reduction in cost. There's an improvement of the experience. Filling up caches can be challenging because that's something that needs to be financed. And there's also the risk of people sharing all these caches. A network without a cache won't be shared. It can, but most users would not. There's a negative aspect to this because if everyone has a cache, each cache then needs to feed itself from the start. So the new problem we are facing is that these caches need to be refilled. You've got 3 networks, and you need to refeed the Facebook cache, for example. And you would be using bandwidth and multiplying it by the number of caches that you would be trying to fill up. So when you start thinking of all the caches at a national level, you can see some of the setbacks. Each cache needs a certain amount of megabytes per second. So you've got those number of megabytes per second times a cost times the number of caches, and that gives you a national cost. More time evolves, the more some of the transitory prices reduce, but the quantities are increasing. So even if prices are reducing because of competition, the quantity has been evolving and increasing. So what do we need? Well, we need to move to attracting CDNs, caches, to come and use our exchange point. Beyond networks with A and C, now the CDN is connected to the IXP, and they pay for their own transit to then be able to send and receive various elements. So here it reduces the cost of transit once more, and I would say it's very positive. What is important is to be able to see what is a favorable environment to be able to attract the CDNs. You've got intermediary availabilities. So implications in terms of rules, when you have content, you need to have an environment that will take all of these things into account. These stakeholders should not be worried, legally speaking, if there is content that does not match up with local law. You could have other systems to take care of that. So the ecosystem is always evolving. CDNs are starting to come to all these different IXPs. The cost of traffic transit is being reduced. And everything that is just used now in transit is everything that is not part of a cache. Dynamic content, that is the traffic that comes out of this network to go back to other networks. What about the top level? The one that we should all aim for. We've got the CDN who's about to arrive. And you've got all these different sets of content that have been generated, created locally. You could have different types of services, government services, or maybe you're a local producer of content that is musical, educatory, cinema. The ecosystem with A, B, and C is slightly larger. There's content that goes beyond CDNs. We're starting to see services online. There's health, education services online, and this gradually creates the digital economy of a country. And that's what we need to work on to reach our objectives. It then generates more investment in infrastructure. We saw what has happened. So I think in ecosystems like this, are present in various places of Africa. So that is what we want to be able to achieve in Central Africa. To conclude, we need to focus on policies and regulations because all of this will not do it in itself, on its own. We need to come up with new rules, legislations from the politicians. We need to allow for a dynamic peering ecosystem. And then obviously we need to develop more infrastructure. Does the country attract investments, local or other kinds? Are there different financial models? And so on. We also want to focus on local content and physical goods and delivery. We want to host international content locally. Recently, there have been some fiber cuts in FIM, CCUT, EZ. Most of the services were provided by HS. I think authentication on Microsoft was not hosted locally. Everything that is in the cloud is hosted in Southern Africa, but when there were some of the marine fibers were cut, none of this was functioning. Outlook, Teams, all of it was gone. And so we want to create ecosystems that we will then protect. But for our discussion today, we just wanted to cover, these different points. Thank you very much for your attention. Landry, you've got the floor. Landry, can you hear me? I can see him connected, but I'm not sure. I think Landry is in the backstage area. Maybe go get him.
Okay. Enoch, can you help move Landry and Olivier in the... Yes.
Allô, vous
Thank you.
m'entendez là?
Hello, can you hear me now?
Oui, Landry.
Yes, we can hear you, Landry. Apologies, my connection dropped, and when I came back, it took me to the backstage area. Thank you, Ghislain, for this general overview. Thank you for all these details. Very often, when we mentioned IXPs, we focus on technical aspects, but we forget some of the economic aspects that you have now covered. What I thought was very interesting was, well, there were a few elements I thought were interesting, but it's when you were mentioning transit and this notion of security. Would you be able to tell us a little bit more about this question of security in local areas and why there is transit to international areas? I also appreciated seeing the equation on the screen of speed, distance, and cost. They are essential elements to figure out costs. We have seen a few solutions that are often implemented by operators, and that is the use of caches. What we often also see And I'm just going to use my own environment for this, but there are many operators who turn towards caches as the ultimate solution to reducing costs. But as you showed us, it's only one of these solutions, one of the options that can lessen the burden, but there are many other options. And one of these better solutions is peering. So that's all I wanted to say. Maybe you could reply to my security question, or do you want to go to the floor for participant reactions? I don't see any reactions in the Q&A section, so I'm going to give you the floor for this first question. Thank you very much, Landry. I can answer that quickly. Maybe I'll then wait for Sylvain's presentation and see if there are further questions later. So when traffic goes between your network, my network, there's just a switch. For example, GABX. There is no intermediary. So the switch is transparent as a layer 2. There's only internet frames going through. And if there is nothing else, I know that traffic will go from my network to yours and vice versa. So there is no intermediary aside from, the exchange point that's just network equipment that is a layer 2 equipment. It's not something that's particularly smart. But if we reduce the number of people who have access to traffic, automatically we'll be reducing the various possibilities. Possibilities for readability, or all those who want to see maybe what's this traffic doing, and so on and so forth. I know that some people encrypt their traffic. When you post something online, they might not decrypt it, but they'll decrypt it later on. So even if today there is no technology that can decrypt TLS 0.5 or different types of crypto, I think in the future someone might be able to decipher it. So the least amount of actors have access to the traffic, the better. And if one of my users accidentally sends traffic that is not secure and not encrypted, then I'm sure that in my network, I won't read this. It will be passed on to GABX, and GABX will pass it in their system, and the person will be protected. So I think peering covers these 2 points. So getting back to the question about equation, distance, costs, caches, as we said, it is a solution. It's there for static content, but dynamic content, it doesn't work. To have dynamic content, you need to have a bigger presence. You need a big service, be it Facebook or Microsoft. Some services may be hidden by the Microsoft Connected Cache or the MCC. But all the non-dynamic things are not in the MCC. So Microsoft could come to GABX and connect themselves as a Microsoft POP. It really depends. Having minimalistic caches is a positive thing, but I think we also need to have Microsoft or Facebook who get attracted, because that is also something we need. But that was just my answer.
Very well. I've not forgotten the other questions. Maybe I'll give the floor to Sylvain first, and then I'll go back to the questions. Yes, indeed. Okay, very well. Thank you very much for this. It's very clear. Now we'll move to our second presentation. It's Mr. Sylvain B, who is the co-chairman of the Central Africa Peering Forum. So I'll give him the floor. Thank you, Sylvain. Thank you very much, Landry. I'm also the co-founder of the Seminar, which is the network for operators in Cameroon, and I'm also a citizen of the sky. That's how I define myself. So thank you very much for giving me the floor. Could Enoch share the link, the content of the link that I just gave him? I'll try to explain a bit and develop a bit what's that. You want me to put it on? Can you put it on the screen? Yes. You just give me the main text. Yes, that's great. Yes, thank you, Enoch. So what I want to talk about is we talk about peering, but in the practical way. Ghislain has just presented all the technical and economical aspects of what's happening in the production of internet. And I want to talk to you about other points, and with a different point of view. It's the point of view of the user, the one that doesn't know anything about what we're talking about here. It's very important as well, because if you look at things that way as well, you give the opportunity to people to think twice before they make a decision. For not accepting traffic coming from another operator. We are waiting for them to send it very far away, and then it's coming back. So that's the kind of thing I want to talk about. So the first one is ecosystem, local peering. Then what does that mean, this local peering, local traffic, international traffic, services that come through IXPs, problems, causes, conclusions. We are here to give you a landscape of things so that every time you are facing something, you can think, okay, these are the consequences of the decisions we are making. So this local peering ecosystem, there was a slide that was shared in Nico's presentation that was presenting the local peering ecosystem, local peering ecosystem. So we have local actors and we have also ISPs and they give access, and then we have transporters that are just allowing data to go from one point to another. And then we have governments with e-government, so that these are universities and schools. So there are a lot of different stakeholders that are involved in this peering ecosystem. And the fact that different stakeholders are together is forcing upon us to find a place to meet, places where you can come and share things. So peering stakes have been presented by Nico before. And what's a stake then? Well, are we able to interconnect between us if there are more than 5 providers? If 5 providers that are have the possibility to implement what they want, can we connect? I know I said I was talking if I were just anybody, but what does that mean? It means is that if I want to go through one path to transmit my package or give access to my network, I need to be free to use whatever road I want to send those parcels, or I want to use that specific road or give a specific direction to the person at least and say, you are taking that road to take that package to whoever, you see? So that's the routing policies. We need to split them. We have a very concrete example. We have the case of transit providers that are working at local level. They have only one autonomous number of system, and they are here to serve their clients, and they have their own routing techniques. They have ANS, and they want to serve their direct clients or their final users, companies or users, simple users that just want to visit a website or want to read their emails, anything like that. So local content, these are challenges. We need to be sure that this is viable, that we can have local peering for this to be implemented. In terms of what's at stake then is, and we've mentioned it before, there is also the question of keeping traffic. Local traffic is just confined locally. So that takes me to the local traffic point. Local traffic can be seen as everything that I have within my network in terms of packages or requests from users that want to access a service that is locally with another providers. All exchanges that are going to happen that have nothing to do with external traffic and that do not need to go any further. And we had very clear presentation by Ghislain explaining what I'm trying to say right now. So I'm giving the image of 2 routers that want to talk to each other. If they are in the same economic zone, economic area, and we are talking here about the ECCAS, or the SEMA one, that's the one we're talking here, we have those challenges. We want to keep the traffic local. And what is impeding us from doing it? Because it's our content, it's our traffic, and we are also consuming those content. And when we ask a request, we make a request to access those content, they don't come to us because it went all the way through a transitory provider. It's good, this provider is here to help us, and like content delivery networks, services that are outside and that are so and are so interesting to us. Every time we have a tendency to use social networks. Is there no social networks in Africa? Could we have one? Can we even think of having a local social network in Africa, for instance? International traffic is highlighting what is not there locally. But there are local economic actors that have something to share. We have a market where we have people that are coming in with services or goods, and people coming with money to buy those services and goods. And if all these people, these areas could be present, if I take the example of Douala, and if you have the clients here, you have the service providers, you have the clients, I don't know, let's talk about a town hall, for instance. Town hall is offering services to their citizens. Why would that town hall, the server of that town hall, why should it be in Yaoundé? Why? I think it should be hosted locally. I think there should be a local server for that, because they want to access and not wait for a long time to access the web page. And it might it's also risky. It's costly, but it doesn't even guarantee the stability of the communication. And the further away it is, the more costly it is, as we've just seen before. It's to the best effect. So there's no guarantee in internet transactions. This is why it's really important to shorten the path as much as possible. We need international traffic because we have one national communication, but internet is a unified network, so we can't close ourselves to the world, of course, but we need to have local traffic stay within our borders, and this is a huge challenge for us. So the services that go through IXPs, there's a lot of services that could be provided by IXPs. We've seen before, as Nico presented, services that IXPs offer. First of all, they offer a platform where you can connect in many countries, except a few ones where there is no IXPs yet, but most of them have at least one IXP or two. So we can try and identify what that IXP can bring. It can bring quite a lot. For instance, we've talked about one of the difficulty that was presented, which is how or why do IXP not publish the traffic that they have, how dense it is, and in the local traffic in this IXP. Why don't they give us data on that? Why is it not common use to do that? Maybe Bruno is mentioning it in the chat. Maybe you could tell us in the chat box. Maybe once we know that, we could see why we've got enough content, but the traffic at the IXP is not big enough. We have the possibility, because there is an internet service that is called DNS, and DNS, it's a service which is critical, because almost all internet users are using the DNS service. When you need to translate a name or an address, when we put the name of a website or the website address in a navigator, it's one of the processes that is starting. There is the resolution of the name, and the resolution of the name is bringing a root server of the DNS to the first server that have the lower view on the name of the domain. So .net, for instance, or all these domain names, all those services. Very often, root servers are hosted outside of Africa, but there are still instances, Anycast instances, that are connected by the Anycast services, and this allows that locally you can have the same service as if you were locally based. So this is something about domain names. For instance, if it says .cm, that could be done locally. IXP should be doing this. If they're not doing this, this is an issue. It should be done. And there are associations that are supporting the implementation of this. Another service as well that IXP should provide, for instance, when we have what we call domain names, the DNS areas, IXPs can have DNS services to ensure the resolution of those DNS. So this is something that can be done as well. There are many other services that IXPs can provide, or if there are some. One of the stakeholders that could make possible the local access to this service, well, IXP is one of them. It's a good it's a good one. But first of all, we need to get the agreement of all the stakeholders and operators or providers. Still, if this is happening, we still need to be careful to not create unfair competition between the different providers. There are different services that could be offered by IXP. You need to think of what can be done. Another service has been mentioned already is the question of cache. We can have a convergence of caches. This was mentioned previously by Ghislain. Cache can be mutualized. We have an example in South Africa. There is a community in South Africa that deals with cache in a coordinated way. And in Congo as well, we have in DCR, we have a good mutualization of cache and how we deal with external content. If we could download just once content that are not constantly downloaded, that would be a cache, and that would be what a cache would be here for. So what are the issues we have? Unfortunately, I didn't get a chance to measure things exactly, but if you test things in your country and you ask for a service that is hosted by another provider, very often you will notice that it just goes outside of the country and just come back in. So that's exactly what we want to sort out, encouraging local providers to work together. What do I have to say on reasons? Why does that come from? Very often, we don't share resources. Why do caches stay isolated? If you have 2 caches, every time there is a request sent in, it's spent twice because it's coming from each cache. And it's losing money. If he transitory had thought of that, he would have refused that because it just makes sense. You know what I mean? It's just it's not common sense. I've got a scenario that I want to share with you quickly as a sort of conclusion. This scenario is there are 2 stakeholders that are peering, exchanging. They are on an IXP. They have their own routing policy. They can transmit their routing information freely. They're free. They can say, if I want to access this network, you can send me all the traffic you have. And they say, you can send me that traffic, you can send it over here. I know who it is. It's fine. This is a liberty of the provider. They have their own policies. But if we want to keep the local traffic, if I don't get back my traffic as soon as possible, the other stakeholders, the other participants in this IXP will say they are happy to transfer to me the traffic that is mine. And if I say, no, send that to my transitory, you know, it's him that deals with all of this. Or send that to your transitory, even better, send that to your transitory. So then he will send it to my transitory, and then my transitory is going to send it back to me. And that means that we pay when we send the data or the information to it's my neighbor in terms of the IXP. It's my neighbor. He's sending it to his transitory company, who is then sending it. He's paying for that, and then his transitory company is asking to pay to send it to the other transitory company. When the other transitory company is he is also asking his client to pay to provide that information back down. And when the exchange comes back up, there are costs everywhere. And that's what we need to think about. The day when I will say to another local stakeholder who has traffic for me and say, don't send it to my transitory company, because, and it just goes straight to me, then it will save money. Because, you know, even if it doesn't go through locally, it will go through in the end, even if it goes outside the country. And so we don't really worry about it because it's happening anyway, but we need to think about it. And we need to use those IXP in the sub-region. And can we have IXP in the sub-region that could be responsible of this, of I don't know, being a center to centralize this and this transmission of data locally at the level of the subregion, at least. It's really it's hard to imagine the ecosystems as one and to have it as we would like it to work. I know it's not something simple. I know that there are issues to overcome, but everything that needs to be done could be listed at least, so that we can think, okay, with actors, with the people that are making decisions in the sub-region, they need to know what needs to be done and what resources we can allocate so that we can help and support these projects. Because there are projects that are funded, but they don't necessarily answer the needs of a realistic and practical functioning of an ecosystem like the one in the sub-region of Central Africa. So this is what I wanted to share with you. Thank you very much, Landry. I'll give you the floor back.
Thank you, Ghislain, for this excellent presentation. You have raised quite a few interesting points. I think we could now move to our Q&A section. I see a comment in the chat by Josué Isamuna, I think. Someone was saying that this was an interesting presentation. Apologies, your interpreter cannot hear the speaker. Can you hear me again? Apologies, I had an issue with my connection, says the speaker. So I was saying that we are now moving to the Q&A section, and I received a comment from one of the participants who said that our speaker raised certain issues, and José suggested that maybe the issues were linked to mutual mistrust, distrust. So is it because there isn't enough trust amongst the various operators in the different countries? What do you think? The question is probably for Sylvain. Thank you very much, Landry. Thank you for this comment. I think that's a good point. It's a good guess. There is a lack of trust But this lack of trust has a cost, and the calculation of the cost was shown by Ghislain. And I think we need to maybe focus more on the cost. We constantly hear about costs. And I think we need to focus on this. If we stop at this question of mistrust or competitivity, competition, those are things that should be dealt with by the various marketing services or departments and other sales units. But when it's a technical aspect, then that's not the same. We've shown that technically speaking, these are different things. For example, if there's a cable that is cut, the consequence of cables being cut, that mentioned by Ghislain, this made the operators give the rights to one of the operators, the one who was managing all the transits, so that they could then transmit the package. So the operator was the one who had to transfer the transit because they had alternative routes. So I don't know if that's a way of bypassing this mistrust when it comes to technical problems. I think in marketing terms, yes, there's probably mistrust, distrust, it's legitimate, but when it comes to technical aspects, I don't think there should be a lack of trust.
Merci, Sylvain.
Okay, thank you, Sylvain. I can also see a question for Ghislain in the Q&A section. So, Mr. Ghislain, how do you explain the interconnection rate being so low in DRC with all of these exchange points and the attractivity level that is so high for foreign peers? All the countries with two hosting infrastructures have a high interconnection rate except DRC. What is this due to? Ghislain? Yes, thank you. I read the question. I can try and answer, but I think the best person to answer this would probably be Nico, who's already on site, and I think he can probably answer that question better than I could. Yes. Nico, I see your hand is up. Would you be able to take this question then, please? Yes, of course. So the IXP is doing its work, and that is to facilitate and attract content providers. Content providers are on site through the cache. I could maybe cover data centers. The two data centers we have are small data centers who do not have a vast capacity and therefore cannot take on too much, and they cost quite a bit to run. To your second point, what is the content that is the most consumed in DRC? In DRC, we often have content on Google and Facebook. I think this is probably similar all over the world. But if Meta is down, you can see this in all the IXPs. It has an impact on traffic at the local level. But on our end, as a IXP manager, we have tried to provide this content, Netflix, Facebook, Google locally for the users. We've also got PCH and others, but that's what we've got on our exchange point. We do the best we can. We do our work. We allow operators who are the transporters of digital data to be in relations directly with the user. But that's where we stop. We cannot become the state. The market regulation of prices is another institution entirely. We've done our work. We've made services available, the quality of services in DRC. varies from one place to the next. Even within DRC, the quality varies. If you go to Kinshasa, for example, quality is quite high, but if you go to more remote areas, obviously the quality is different. But with the arrival of data centers, once they're open, I think this will probably allow everyone to be able to host content locally. I think things will decrease, but then it will increase again later. For the person who asked the questions, I would say that remember that for the last few years, the price of accessing the internet through operators is reducing. There is a decrease in price. It is not what you might be expecting, but if you compare it to 3 years ago, what we were paying for 20 megabytes and what we pay now for the same price, you have more data, i.e. you're paying less per mega or gigabyte. So that's just my answer to this question. Very well. Thank you, Nico. Thank you for coming in to answer that question. I hope Mr. Bakungu is satisfied with the answer. And there's a second question from Mr. Bakungu, but we've also got a question from Prosper Niagabo. Thank you, Mr. Ghislain, for the presentation. I was very interested in the economic aspect of IXPs to exist and contribute to the reduction of costs for internet and IP transit in a country. They focus on Mr. Nico's presentation on the issue of resources on management of IXPs. And his question is, how can IXPs gain money to be able to make the infrastructure for IXPs function properly? How can IXPs earn money so that they can manage the operations of the IXP? What are the possible origins of financial sources to have IXPs function properly? What business model could exist between IXPs and CDNs? So that's Prosper's question. I think it's a mix of questions. We have had multiple speakers. Even the speakers from the first session can come in and answer this if they feel like they can. So I'm going to give the floor to maybe Ghislain, Sylvain, or Nico. I can try and answer that. It's a good question. It has multiple aspects. I think you've touched upon various points or raised multiple points. So when it comes to the last point around financial aspects and management of IXPs and resources for the management of IXPs, there are various management models for IXPs, but the one that obviously it depends, there are commercial exchange points, in which case the financial objectives are very different. You know, they need to earn money, they need to make money, they need to sell, they have imports and exports. But there are IXPs who focus on being able to generate enough to cover baseline costs, minimum costs, to just stay afloat. There are certain exchange points that are managed by governmental agencies. The financial resources depend on the model. There are certain IXPs that function in universities. We see that in Latin America, for example. And in those cases, the exchange point is maintained, supported by the university. There's commercial partnerships. They earn money by paying per type of port. that you use. Others cover their fees via donations. For example, if someone donates money to the Internet Society, then that money may get passed on. The objective of an IXP is to reduce costs as much as possible so that the cost doesn't then get transferred to the person using the IXP to connect. There are certain IXPs who do not have staff, there's just volunteers, and they spend maybe half a day a week or 2-3 hours per week to help maintain or function, like help support the IXP. And in those IXPs, they try and decrease fees so that everything can keep running properly. And if there are fees, then they're there to kind of keep the IXP running. What we have seen is that a lot of IXPs try to reduce costs, especially, and one of those main ways of doing that is not having permanent staff or any staff, just volunteers or a partial team. But obviously you need ways of financing. There are also exchange points that belong to data centers, and the service is provided for free, but the hosting is not. So you've got cross-financing, so you would have finance through another service that is also provided by this organization. So it's just various models and different business models that can be used in the running of IXPs. And for your question about IXPs and CDNs, I think CDNs must be seen as full proper members. If Nico has an operator today, for example, Orange, the CDN and Orange are at the same level. They are networks paying fees like everyone, and so they are equal. There's one maybe exception that Sylvain mentioned, was people who provide DNS services, PCH, or secondary DNSs from Afrique. They provide a service for the community, and the community doesn't pay. So it's pro bono work. And because they provide the service, the IXP can offer this pro bono service also. Generally, it's something quite low, not the highest kind of speeds, but it's offered for free to the community. I think maybe I could conclude on the fact that you need to maintain neutrality between IXPs and CDNs. The CDNs need to be considered as full members, but the IXP must remain neutral and treat everyone equally and not favor one type of member versus the other, unless there's just one pro bono service for the whole community. Thank you very much. Thank you, Ghislain, for this reply. I think we're coming to the end of our session. I'm just going to ask maybe Nico or Sylvain to see if they have anything to add on those points, or shall we conclude our session? I think Nico has his hand up. Yes, I just wanted to share my experience with the presence of CDNs in exchange points. It is it can be tricky. CDNs can be quite capricious. ISPs are defiant. You need to explain things to them, explain why they need to be here, and how the load can be shared in terms of accessing CDN content. The CDNs, as Ghislain said, should be contributing to the financing of the IXP by paying for the fees. It's one of the main resources for the functioning of an IXP, but in DRC, we have faced capricious CDNs. They've said, we're coming with you, but we do not want to take charge of filling our caches. You will have to take care of that. And it took some efforts, time. We went back to the operators, re-explained the importance of working together and sharing all of these elements. Once all this was clarified and all operators were on the same level, they said, okay, we will deal with bandwidth of securing these caches for the different CDNs. So just to tell you that they are there on that port for free, they use our subnetwork to be able to propose services, and the model functions, it works. But it is a model that later on in the future, this business model might need to be adapted to reality so that CDNs also pay fees, because our initial intention was to get them on board. But now together we need to see if they will start contributing in addition to being on board. If they don't give anything, then the community needs to pay and is in charge of updating their servers. And we don't want the burden to be placed on the community. Noted. Thank you very much, Nico, for those additional points. I think we're coming to the end of our session. So to conclude, I will give the floor to Ghislain or the president. Sylvain, maybe? Yes, thank you. Thank you for being our moderator and for giving the floor back to me. I think that to conclude, I will just keep calling people out and trying to ask people to be autonomous. Remind people to think about the packages they're producing and ask themselves if they're arriving locally to the end recipient. Have I checked that packages I'm receiving are locally hosted? Do the operators have a direct access to transmit the packages I'm trying to access? It's a continuous work, and I think we need to keep raising awareness, asking these questions, and separate these marketing issues from the technical and operational issues. Thank you very much. Thank you very much. Thank you, Sylvain, for these closing remarks. I think we can close this session. We will be going for a 1-hour lunch break. And we will be back here all together at 3:15 Universal Time. So at 1/4. So we should all reconvene here in just under an hour. So it's currently 1:15 in Central Africa, and we will see you at 2:15 Central African time. So in just under 1 hour. Thank you. See you later.
Afro, Afro, whoa. Yalala, 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 yalala. Yalala, 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 yalala. Afro, Afro, whoa. Yalela, 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 yalela. Yalela, 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 yalela. Afro, Afro, whoa. Yalela, 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 yalela. Yalela, 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 yalela. Afro, Afro, whoa. Yalela, 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 yalela.
Thank you, Enoch. Thank you, thank you. Can we do a quick test from Amrish, Jean-Baptiste, just to see if your sound is working okay, your image is okay? Yes, Amrish.
Bonjour Ghislain.
Bonjour.
Hello.
Bonjour tout le monde. Bonjour,
Hello, hello.
Ghislain.
Can hear you, can see you very clearly. Kudia, can you hear us? Can we see you? Kudia, can you hear us?
Hi,
Okay.
bonjour tout le monde.
Bonjour, Kudia. Ok, d'accord. Okay, so I don't see Sylvain. Okay, I think we can start. On peut commencer. Enoch, you can probably put the holding slides and then.
I think we can start.
OGB, can you?
Yes, I can moderate the session, Ghislain. No problem.
Okay, please proceed.
Bonjour tout le monde et bienvenue.
Hello, everyone, and welcome to this last session of the day on the Central African Peering Forum. As mentioned this morning, it will be a more technical discussion on 2 points specifically. A technical presentation that Koudia will do. And then after that presentation from Koudia, which is more on the technical aspect, then we will move to Hamrish. Hamrish will talk about internet measures and will present a platform that will give you an overview of what we can do with data and measures and what impact that can have on the quality or resilience of internet with a specific focus on Central Africa. Koudia, maybe we can start with you. Maybe you could present yourself and then give the floor to Amrish so he can present himself, and then we'll get back to you and you can start your presentation. Thank you. Koudia, your mic is off. Yeah. Hello, everyone. I hope you can hear me well. Yes, we can. Thank you for inviting me to participate to this session on the technical aspects of peering. It's not easy to try and talk about all the technical aspect of peering and EGP. So we'll try to go to the main points. So I'm presenting myself. I'm Koudia Gay. I'm a network engineer and system engineer, and I work in the digital university in Senegal. Allow me to share my presentation with you. And I'm also part of the trainers in the internet community in Africa. Sometimes I'm also a trainer for the Internet Society with with the NRCRC or AFTD and other organizations. So I'll share my screen. Koudia, you should be able to share your screen. Yes. Can you see my screen? Yes, we can see your screen. It's all good. Yeah. Can you see it properly? Yes, it's perfect. So I'll try to summarize the different points. So I want to remind you what is the BGP, which is the main protocol of montage in internet. So we'll talk about the different specificities of BGP, the best practices and the internet configuration in Senegal. And the positive side of having an IXP and the downside of not having any. For the concept, as you know, the technical aspect, I think most of the participants know that. That's why it's just an overview. So the routing protocol BGP, Border Gateway Protocol, is a protocol of routing that is used to exchange information on routing on internet. That's the main protocol. It is used by ISPs to buy information from their ISPs, but it is also used at ISP level, but also in IXPs to do some PRN. So there is a routing protocol that we called an exterior gateway protocol. What does it mean? It means that it's a protocol that is used between two entities or different entities, because parallelly there are also interior gateway protocol, IGPs, and the BGPs work alongside the IGPs or the OSDS or a different kind of protocol to facilitate the exchange of routing information. So this is a standard that has been described and defined in the RFC 4271, and the particularity of that BGP is that it's an autonomous system, AS, and it's something that we use in Africa. So people that use a prefix in Affinix, I think you should get an ISM, because it will give you some freedom on your prefix. So that's the basic element, I believe, on which the BGP is based. So it fonctionne également on the TCP port 179. So as we know, with the TCP EP protocol, they all use different port numbers for their transport. So very often it's TCP, sometimes it's UDP, but in this case it's TCP. So for the BGP, we use the port 179 TCP. So the characteristic of BGP, it's a path vector protocol. What is it? The routing dynamic routing protocol are classified in different categories. Mainly, we have protocol classified and in link states. They use the shorter path. And then we have algorithm that we call vector distance. So the distance vector calculate the distance to say whether it's shorter that way or that way. And then we have BGP that is also a distance protocol to a certain extent, but it also calculates the information on the path to get a package somewhere. So it's a broader kind of protocol that gets quite a lot of information in. And the updates are incremental. So they are not updates contrary to other routing protocols that have updates that will take all the information on the routing table. What that creates some flexibility in this BGP protocol, because we can configure different parameters to influence the traffic that is coming in and coming out. That's what we call routing policies. We'll implement different strategies, different policies, different on the peers and depending on many other things. There are many options available. So the BGP is also classified as a classless inter-domain routing. What does it mean? It's just a little reminder. We have routing protocols, the oldest one, that used to send or were not able to send to other routing places variable data. So this one is able to do that as is sending something if before it was not the capacity to convert information, now it can. I could not send a slide 17 or 27 or 12. So this is a routing protocol that can go much more into details on masks and send variable masks. That's what we called classless inter-domain routing. So it's the most used protocol on internet nowadays. So the path vector protocol, as we can see on that drawing, is the AS number, which is the key element, and the information is shared between one AS to another one. So it's the prefix and that are shared and other information, and it tries to identify what's the best path, because when we're talking about routing, we leave a point A to reach a point B, but what's the best path, the most efficient one? There might be a few different ones, not an infinity of paths, but with underwater cables between countries and the need for redundancy, sometimes we might have a buckle somewhere, so there are different paths that are possible. So our routing protocol tried to use the best path in terms of performance, viability, and how trusty it can be. And the fact of having other routes allow you, if there is a problem on the initial route, to use the second route found without having a lack in the service. So one small thing I want to remind you as well, we are in a forum where we are talking a lot about peering, and sometimes there is a mix between transit and peering. So it's important to remind you what's the difference. So when we talk about transit is against a payment. I work at the Digital University in Wabinukan. I do DGP with my transit provider. They give me access to internet and I pay for that. There is a fee. So you need to pay for that access to internet. So for instance, I say I need 1 giga of bandwidth and I pay for that. Contrary to peering, today, the example I can give you as IXP in Senegal, even though if it's not operational, I can connect to Senex in Senegal, which is an IXP, and I can exchange information and with another entity, another university, for instance, or it might be, I don't know, or other structures, other bodies, and it's a policy that we implement, and we create some parameters for this to happen, but I don't need to pay that partner for this to happen. That's what we call peering, and we are exchanging. It's something that is deliberate. We do this exchange of routing information, and this is to send traffic when there is no explicit correspondence. It's important to remember that because there are many engineers that are making that error, because the router, if you're not defining the route, it's not meant to know where to go. So it's not something that is natural for a router. So every time that a road is explicitly defined, the router will go down that road, but you cannot define all roads on one router every single time. So it's important to tell the router how to take those packages where they need to go, even if it's not explicitly defined. So that's why it's really important to have a default route. So the BGP algorithm, you have to understand that in this algorithm, there is what we call an incoming process or an outgoing process. So for the incoming process, we have the BGP between two peers. Those two peers each of them need to go give prefixes. I use 172, 16, and other numbers. We all need have to agree and say, this is my prefix, this is what I'm showing, and the other one needs to do the same and show its prefix, so that with our incoming process, we need to accept that partnership with your peer, and that is suggesting that prefix. So if it gives you that prefix, if you accept it, it will come on the routing table. If it's not accepted in your routing policy, it will go straight to the bin. And it's based on this that the router will create its BGP table. So as any routing table, each protocol needs to maintain its BGP, its routing table. So BGP will have its own routing table, and from that, we will be able to fill in the main routing table of the router. You will have the static, dynamic, AGP, BGP, and so on. On the BGP table, we will also have if there are double paths, they will also be put onto the routing table, but we'll say, okay, that's the best one out of the two, for instance. And from that routing table, there is another table that we call transfer table, and the forwarding table in English, sorry. And from that routing table, we will give information to the forwarding table and say we want that package to go to this place and so on. So that's the process for the incoming process, and for the outgoing process, we will look at what the best path are from the BGP table, and we will define the best path, the best pathways by defining a few parameters, and to do so we'll apply the right policies because we might have preferences to this route rather than another route because we have the best quality of service. But for instance, if you've got a hacker where or a client with whom the quality of connection is not good, you might not go to them, and you might go to someone that is giving you a better quality of service. On the BGP, I wanted to remind you a few things. BGP is used in two ways. We've got the iBGP and the eBGP, internal and external. We do in external BGP in autonomous system, but in the level of the ISP, yeah, we've got iBGP that is used to carry part of all internet prefixes through the ISP backbone. So when you're on the backbone of the ISP, and for instance, in a university, you are doing eBGP within your AS, and you do that with the external AS. So eBGP is used to exchange prefixes with other peers, and eBGP is also used to implement the routing policy because it's an autonomous system that is different. Because within a different autonomous system, you have the same routing policy. So on the configuration, you have the BGP router, and you put the number you do. Network you are announcing, and you've got the neighbors with the ISN remote -AS101, for instance, and then you define a list of prefix clicks that are like a route map to define, to influence between the incoming and the outgoing traffic. So this is what I wanted to present to remind you what it is. In theory, I go over that in 5 days, but in my training, but I just wanted to have a bit of an idea because we're in a farm today. So once we've reminded you of that, and we wanted to remind you of different specificities of BGP. So there are a lot of specificities in BGP, and it is important to understand each characteristic because this is what will influence the traffic and optimize not our BGP. So it's a part of an update and then BGP update, and it describes the characteristic of a prefix. So you need a BGP attribute can be transitive or non-transitive. It can be mandatory or not. So there are a few attributes that we can present. The first one is the AS path. It's a sequence of ASs through a specific route. So for instance, I'm in Senegal, and to go to RDC, I have to go through different ASs. So to go through those different ASs, that's what we call an AS path. So for each prefix, the router will know which AS it needs to go through. It's a transitive attribute that is mandatory, and it's used for the detection of buckle and for applying policy. So for instance, we may say, here is the AS that we want to choose rather than another one, but there are other parameters that will be involved. Then another attribute is the next hop. So if it's eBGP, is the external neighbor address that will be taken into account. So in this case, the next hop is the address of the external neighbor. If it's IBGP, the next hop from the eBGP. So it's a non-transitive attribute, but it's mandatory as well. So if it's eBGP, often we configure what we call a group ACK address, and that is what we use. And we will see that the next hop is this, and so that we have the next stop route over the overall BGP instance. We transfer the origin of the prefix. It's a historical attribute, it's transitive, and it's mandatory. It is used in the transition from EGP to BGP because we had the EGP initially. That was what was at the origin that was used during that transition, but it's still an attribute that is still used, and that takes different values like IGP, EGP, and incomplete, because we can redistribute routes either by a static redistribution or an EGP redistribution route, even though it's not recommended under a certain condition. And the origin will influence the choice of the best path. We have another attribute that we call aggregator. So the aggregator, thanks to the IP address of the BGP router, will know the address. So there are different prefixes that have a variable mass, and it is recommended to aggregate them because the aggregation is what allows to reduce the work on the routing tables, because it's transmitting between the routers, and the aggregation is a recommendation because it allows you to summarize different prefixes that have different masks towards one aggregate. So the aggregator is not influencing the choice of the best path, but is highly recommended, and we can do it by using the aggregate address or other mechanism like the comment network. So there is another attribute that we call local pref. Local pref is a non-transitive and optional attribute. It is a local attribute, local to only one AS. And the value of the local preference is defined at 100. What you need to understand is that the local pref is used to influence the outgoing traffic, sorry. So it's different to what we'll see afterwards, which is the one we use to influence the traffic outwards. So you can define the route by defining if we want to influence our outgoing traffic to go towards one link rather than that other one. So then we need to increase that. The other attribute I wanted to present was the MED, multi-exit discriminator. It's a non-transitive and optional attribute. It is used to give a relative preference to some entry points. It determines the best path to the incoming traffic. So if we have two paths to one ASN, we can influence the traffic. Imagine that we are at 1 giga and we want to go to 100 giga. We can modify the MED so that the incoming traffic comes through the 1 giga link rather than to a few hundreds mega ones. And in a case, I need to undermine the value of the MED to influence the incoming traffic.
There are other attributes that I will be discussing. They are important to be able to influence BGP traffic. To recap, the BGP algorithm, the first thing to take into account is that we cannot take the road into account if there is no route. That's an important rule to bear in mind. Sometimes engineers can do BGP troubleshooting, but the problem comes from the fact that there is no route on the routing map. If the route is not present on the routing card, then BGP will not be able to transfer anything. That is why often, to avoid this kind of problem in workshops, we create a route that we direct towards the null, the 0, even if it's later going to be deleted, because it allows BGP to integrate this route into its algorithm. So that's rule 1. Second rule is to not consider an iBGP route if it is not synchronized. So that's fundamental because your iBGP instance in your ISM is crucial. you need to have that synchronization so that BGP can work. We also use the highest weight, the local pref, the highest. As I said earlier, you should favor a local origin route over an external route. And you need to use the shortest AES path to go from point A to B. You go through multiple AESs, and you should favor the shortest path. So the origin code, the lowest that you can. So you've got the IGP inferior to your EGP, inferior to your incomplete. So then you've got the lowest MED. And finally, you should favor the eBGP path rather than IBGP path. So the path with the IGP metric needs to be the lowest towards the next hop. For eBGP paths, if you have multiple active trajectories or paths, then you should install parallel pathway end pathways in the transfer table. Because in that case, if you have a problem, you can move from one path to the other. If the ID router is the same, move to the next step. If the ID router is not the same, then you should select the oldest path. Kudia? I know that you've got a lot to say. Could you maybe summarize? Yes, I understand. Fantastic, thank you. So you need to use the lowest router ID and a few other points. So that's just a slide to summarize the best practicing. I won't be able to go into detail today, but you've got a few good practices. You've got optimization techniques, updates. You've got per route refresh, peer groups, route reflectors, and confederations. There's also techniques for scaling up, soft reconfiguration, and route flap damping. So you've got BGP best practices, and I would encourage all our participants to consult all of this to find out more best practices, good practices around BGP. Certain practices may be obsolete. So that's what I wanted to tell you on the technical aspect of things. If I have one more minute, maybe I could tell you about Senegal. Yes, of course. So for Senegal here, I wanted to mention it. It's a specific case. In Senegal, we've got 6 underwater cables. And the first one, SAT3 WACS. We've got Atlantis 2, we've got ACE, main one, Share. That's a new cable, Share Cinema. It's from our society, our company, Cinema. So the Senegal Administrative Services. And finally, we've got the 2 Africa transatlantic Facebook cable. So Senegal really has capacity. We have potential, and now we need to strengthen our capacities. In terms of data, I contacted Afrique and wanted to gather all this data that I'm now showing on the slide. Here you can see that there are 15 members and only 10 have done their UP on the internet. The other ones may not have put things online just yet. Senegal is a country that wants to see real digital transformation and development, but we need to see improvement in the situation. I would invite entities such as ISOC or Afrique or others to raise more awareness with the stakeholders on the importance of all these issues. They are not just technical issues. I also mean the development of digital economy. We really need to have these resources. And we need to have operational IXPs. So that's just a touch upon resources. And I also have a case study from my university. Today, we have more than 70,000 students at the digital university. We run different programs for training online. We do not have enough bandwidth, just around 660 megabytes per second, and that is not sufficient based on our needs. We've got 20 browsing providers. We've got our own IP address. Sometimes these are IP addresses that are made available by operators. So the state gives our students an internet connectivity during their schooling or their university years. They have a subscription and a laptop. And the student, depending on the 3G cover in their area, will have a internet connectivity. You can see one student could have a subscription with Espresso, but could access a training platform that is hosted on an Orange IP address website, or it could be hosted on another IP address, but it could also be on our peer. But the absence of operational IXP in Senegal, when I say there is no exchange point, some people might say there is one, but the traffic exchange between operators does not happen at the exchange point. I think it's probably, complicated having a subscription with one provider and you cannot necessarily connect to the other ones. The student will have to cross the entire world before he gains access to the site he was trying to gain access to. So there's deteriorated performance because we do not have a properly operational IXP. So I would really invite all the stakeholders in all the countries to raise awareness with our operators and politicians. For over 10 years, a lot of engineers who've participated in training sessions on BGP are engineers from AIS, ISOC XS, NSRC. I think it was a partnership that ISOC had created with the African Partnership. But despite all this training, many ISPs are still reticent to joining a local ISP, even if it exists. And so I think the technical aspects are very important, but the public policies, the local community, and the people who get to define the business model are also very important. They need to work together to see which mechanisms there are and how they can get people to set up an exchange point and make it operational. It needs to both be operational and perform well. Because if you can't have an IXP that then keeps having connection issues and connectivity issues. So that's just what I wanted to say today. And I wanted to thank all our participants again for listening in. And I will let my colleagues develop further if they so wish. It's difficult covering.
Je reste disponible pour répondre à vos questions.
Merci beaucoup, Koudia. Et je sais que c'est un sujet que tu développes chaque fois avec passion. Et merci en tout cas d'avoir fait ce rappel de base.
Thank you very much for that. Thank you for covering all those points. Thank you for mentioning the need for political engagement beyond technical aspects. I think it can raise quite a few debate points, and your conclusion allowed us to segue into our final presenter, Amrich, who will maybe try and tell us how to guarantee the quality of the internet, what resilience different countries have, present the situation in Central Africa. I'm going to give Amrich the floor. He will be able to introduce his theme. Maybe you can stick to roughly 20 minutes. And then we will have some time left for discussion. And I will summarize your presentations at the end. Amrich, you have the floor. Thank you, JB. Hello, everyone. It's a pleasure for me to be with you today. Thank you to the organizers for inviting me. I'm Amrich Fokir. I'm a researcher with ISOC. I work with internet measurements, measuring all the different technical aspects of the internet. I used to work with Afrique as a research, development, and resources officer. Today, I will show you a few slides on an index, the Index for Internet Resiliency, which we developed at ISOC. I will also show you the Pulse dashboard that we have been working on. Can you see my screen? Yes, we can see your screen. Fantastic, thank you. So, the goal is to have an idea of the health of the internet. The internet is a complex system that has been built with various components and is distributed on multiple layers, different networks, and we want to assess the health of the internet, but that is something that is difficult to do. So the aim of this exercise, my research, is to try and focus on all these complex issues and simplify them into main pillars that are measurable. The idea was to find indicators for resilience and good health. And thanks to this, we were able to develop a resiliency index. So before telling you about this index, I wanted to tell you about Pulse. It is our dashboard on which we display many different measurements. I will go into more detail, but the idea was to digest all this information, all this technical data on the internet, and put it out in a way that is easy to use, to understand for political deciders or policymakers or journalists who need synthesized information, summarized information to be able to take decisions in their own countries. So to do so, we need data. ISOC does not produce data, except when we work on measurement campaigns. Mainly, we focus on third-party data that our trusted data partners provide us with. You may recognize some of these sources. PCH, I think, has already been mentioned. They provide a lot of data to the IXP. They have various connectors around the world, and that allows us to gather lots of information. APNIC in Pacific Asia, they make a lot of data available when it comes to ISPs, NSX validation, different rates of measurement on the internet. On Pulse, there are various themes that we will be tackling: resilience. In resilience, we have something we have dubbed concentration. As you know, more there's concentration, more the services are concentrated, the less good it is, because this turns into bottlenecks, and if there is an issue, then a large part of the internet could be out of service because of these single points of failure. So if there's too much concentration, there's less resilience. We have also decided to focus on the evolution of key technologies like DNSA, HTTPS, and we generally try and see if the adoption of these new technologies functions well. We then compile all of this into country reports, and I will show you an example of what it looks like if you click on one country. You get given multiple points on the general health of that country. One of the main pages of Pulse is our shutdown tracker, so internet shutdowns. And as you know, unfortunately, we still have quite a fair few shutdowns in some countries in Africa for various reasons. This could be because of an election, it could be because there's strikes, demonstrations, or other cases during exams. Some countries cut access to the internet, shut down the internet. This has a negative impact on communities because people who use the internet no longer have access to certain services, be it bank transactions or exchanging, doing business. It has a serious impact. And so we developed, to this effect, a calculator that we have dubbed net loss calculator that allows us to calculate the loss in GDP linked to an internet shutdown. For each country, we've developed an economic model to try and estimate quite precisely what would be the loss in terms of GDP if there was a shutdown. And it will vary, depending on the time of the day, the number of people, the type of shutdown, and so on. I've already covered quite a few of these in my first few slides, but yes, there's evolution of technology, there's the issue of concentration of services, there's the country reports, there's the idea of resilience. In the future, coming soon, we plan on creating a peering dashboard. We will be analyzing data around peering in each country, and we will try and give indication on how things are evolving in those countries. So that's just to give you a global idea of what we have been doing in terms of technologies. You've got HTTPS, IPv6, and TLS 1.3. We generally consider the countries, the operators, And then Koudia mentioned BGP, but there's also security of BGP with RPKIs. We try and focus on the various resources per country. Now, when it comes to concentration, to run a website, you need a hoster, you need a certificate, SSL, you need a DNS server for a domain name, you need CDNs if you want to host content on a CDN. So these service providers are numerous, and the question is there a real sharing of all the needs amongst all the providers? So here we need to have information about the concentration of services globally. As we know, unfortunately, there is a concentration of these providers. They are not many. Most websites use the same providers. This could be an issue in terms of resilience if one large operator, CDN operator or DNS operator was faulty or broke down. If there aren't enough redundancies, then a large part of the internet could be impacted. I'm not going to tell you about internet shutdowns. It's a very important subject. In 2023, 18 countries in the world experienced an international internet shutdown. We saw roughly 124 events, and in total there were 2,370 days of disruption. And so now, as much as possible, we are trying to track these shutdowns. We have this on an internet tracker online. We're also trying to identify the causes for these shutdowns, which mechanisms were used. And so these analyses show us if there's a problem with resilience. For example, if there's a strong concentration of operators, let's imagine, for example, there's one or two operators, obviously it's easier to shut down the internet. But if there's an environment where there's more competition and there's more diversity in terms of ISPs, it might be a little harder to shut down the internet because the system is slightly more resilient, slightly more protected. So I spoke to you about the net loss, and it focuses on an economic model with analysis of data linked to the GDP and the impacts and events that create impacts. And by gathering all of this, we came up with this model that allows us to draw out the loss of GDP in December 2018, 21 days of shutdowns, $7 million was the economic impact, and that is quite a lot. We also ran a short analysis. Each country was given a shutdown risk factor. So here it's various metrics that give us this information. We also focused on the internet resilience, and that comes from the index that we will be telling you about in a few moments. So we saw that there's almost a correlation between internet resilience and shutdown risk. countries that are less resilient are more likely to have a shutdown risk. And the countries that are more resilient are less likely to have a shutdown of their internet. And so this tells us that resilience is important for the shutdowns, be they intentional or not, to not have negative impacts on internet in countries. So now I'm going to move on to resilience. As I said, resilience, I could say many things about resilience. It would probably vary from one community to the next, but the idea with ISOC was to focus on creating pillars for the internet. We identified infrastructure as an important pillar. So this is the existence and the physical infrastructure. Performance. You can be well connected, but if you cannot perform, it won't work. Then there's the security pillar. You cannot not talk about security with cyber attacks, amongst others. Have countries and networks adopted good practices? And finally, we have market readiness. We wanted to have a slightly less technical pillar that focuses on the market. Is it a market that seems to work? It self-regulates, there's real diversity. There are no bottlenecks. Is the internet accessible in terms of cost? These are indicators that we included in this final pillar.
So each pillar, it's split in different dimensions. So we have the cable ecosystem or the mobile connectivity, enabling infrastructure, and we look at the different data and exchange points. So whether they are IXPs or not, whether they are data centers or not, and how many of them. And this data comes from different points. It can come from ITU, GSMAs, PCH, peering DB, and so on. From the performance point of view, we look at the fixed networks and mobile networks, and this data comes from Ookla. We look at the quality of the data in terms of bandwidth. We look at the speed, but also the latency, because it's also important for the quality of the user's experience. So we measure that as well. And for the third pillar, which is enabling technologies and security. So here we take IPv6, HTTPS, DNSSEC, and the routing hygiene. This is important. It's important to have a security at the routing part, because you've heard of IGPs that were hijacked, because the IGP have been made in such a way that it's extremely easy to hijack the routes. So with the Manners program in the past, there were some things that were put in place. There was a platform where people could implement some good practice, and that providers could implement to reinforce routing in their networks. And we could extract a score. So the more you adopt some of these elements regarding the quality of your routing, and the higher your score would be, and we take that into account. We also have here, we'll look at, say, do you have upstream redundancy? So a provider, if he's got one transit provider only, it's not enough, because if there is any issue, users won't have access to internet. And we would like to have more redundancy to avoid that kind of issue, and to have a few service providers available in case of issue. And then there's all the security threat. With, for instance, the World Bank is giving us the number of secure internet servers, and there is also the Global Cybersecurity Index from the ITU. And finally, we also look at the DDoS potential, which is the entire networks in a country, and we look at how they can be a source of DDoS. And you know that if you don't reinforce your network, if you don't close ports, and you leave DDNS ports open, then it can be used for attacks on other networks. And so we look at that and we collect that data. Cybergreen is collecting that data and telling us whether your network is strong enough or not. And then in terms of the market, how it is structured, there's affordability of it. Is there a market concentration? Is there an hegemony of the providers, or a variety of them? And we look at the peering side as well. We look whether, for instance, how many providers there might be in a country, and how many are present on one IXP. And then we can calculate the percentage of providers available on one IXP by knowing how many there is in the country. So to calculate our index, we need to add what we call weights on those pillars. And we add all that, and at the end, we have the Internet Resilience Index. This gives us an overview of things, and we can give an Internet Resilience Index on more than 120 countries in the world, and we've done a categorization per region. And I'm showing you Central Africa and what the resilience rate is on average. And unfortunately, it's not very good news for this Central Africa region, because it's one of the ones with the lowest resistance rate. And if we look at the countries individually, we have what we call Middle Africa is Gabon, Congo, Cameroon, Angola, the other Congo, and Chad. So these are countries that are the bottom of the line, in terms of resilience. But this said, there are quite a few things that some countries are doing well. The idea when we're giving you that report is that you can visually see where you can improve things. For instance, I've heard Nicole said that in the data centers in DRC, it's not great. But if we look at the entire country compared to the number of population, compared to other countries that are doing it better, the DRC has not reached the level that other countries might have. So there might be something that could be implemented, policies that could be implemented to improve this, reduce the operational costs of data centers. So there might be some more in the number of IXPs. It's not so bad, but it could be better. What we do is we check whether there is at least one IXP per great big city in each country. And I think there are quite a few things that are being done now, so that can happen. In terms of security, with HTTPS, it's really good. IPv6 adoption is not good at all. The DNSSES adoption has not happened yet. So this is to give you an overview of where work is needed. And if you want to go to your policymakers and you can show them where there are issues, because we are going to put in place a DNSSEX program. So maybe this could be something you could sign for. So this is the idea of this resilience index from ISOC. And we also give you a different view by including the internet resilience score, but also the penetration rate, the number of internet shutdowns, what is the IXP operator market like, and that's the overall country report that is also available for each country. And then we also are trying to work on a peering dashboard. And the idea is to really track the evolution of IXPs at global level. We've started to do that with African exchange points. So here you've got the example of Kinshasa, but data stop in August 2023, and we are working on this right now to try have a dashboard ready for July. So the idea is to know the number of connected ASN, the number of prefixes that we can reach if someone connects to this IXP, and to try and see through the years if there is an evolution in terms of capacities, number of AS that we can reach, if you connect to an IXP, and so on. So that's it for this overview. I suggest you to go on the Pulse platform. It's Pulse at internetsociety.org. If you need to know a bit more about the methodology of this resilience index, you can find information there. So if you need more information, please send us, or if you want to contribute, send us an email to pulse@isoc.org. If you think there's some improvement that can be made, or you think this data is not accurate, because sometimes we just don't get the information, or we don't see that a data has not been calculated right. So if you spot something, please don't hesitate to let us know. Thank you very much for your attention. Thank you, Amish. Thank you for your presentation. I think that when you look at the end of Kuja's presentation with yours, it gives an idea of what is the state of the countries and what levers we can play on to try and improve things. We've got a bit of time, so I'll try to go over what has been said. So Amrish presented presented a Pulse platform with a focus on the Internet Resilience Index, which is a tool to give you a state of the health of the internet in a specific region with looking at different indicators. Those indicators Amrish mentioned measure pillars, and it gives us the opportunity to look at the overall elements that give us more visibility, and that can also help to make decisions for regulators or other people, or even the overall community. He also underlined the fact that we all use this. This is coming from different third parties, because the Internet Society is not producing data as such. It's just reaching out to get some data from elsewhere. It has also highlighted the fact that from the Pulse platform, you can have a report per country to understand where you can act. At the end of his presentation, he gave indication on future projects that will give us a dashboard that will allow us to have visibility on the evolution of IXPs, MAN, and the overall traffic in different countries. He's spoken about another tool and the 50-50 vision that will give you an idea of how much traffic is coming from inside or outside one country. So with those activity of research, it helps to get a better visibility of things, how they are, and where resilience should be. Thank you very much, Amrish, for that presentation. And to go back to what Udia presented, Udia went overall the BGP protocol, which is the most used protocol to allow big networks to speak to each other. And she gave us the main characteristics of that protocol. She also mentioned and reminded us the need to make the difference between traffic and peers, so where you peer and when you pay and when you don't pay. And at the end of her presentation, she reminded us the BGP protocol characteristics that are important to know when you work in this specific environment. She talked about the next hub, the ICE path, the aggregation function, and other attributes that are important to think about when you're doing some troubleshooting, for instance, and you want to optimize your traffic. At the end, Udia raised the fact that despite the fact that in certain countries, it's the case in Senegal, but not only, if there is a massive landing of undersea cable, but we realized that the traffic and in the IXP, they don't exchange traffic, which means that the IXP exists, but it's not really operational, and what impact it can have in the university where she works, when her students need to reach some content and they can't because of the underperforming IXP. So this was to summarize the both presentation that we had today. We've got a bit of time, so I'd like to see if we've got any questions that you might want to ask to our panelists. So I'll go to the question, and I see one first question that has been asked by Sylvain, who is asking Kudia whether she could explain the difference between a path and a route. I don't know whether Kudia is still here and whether she can answer that question. Maybe trying to explain because you're talking about the mechanism of route management. And could you have, thank you very much. Thank you, GB. Thank you, Armish, for that presentation. To answer that question, in French, path and route is just the same, you know. I don't know, can you specify your question, or is it a route when you're routing table? Because when we talk about routing, we are talking about one source and one starting point, how you go to one destination, one endpoint. So there are different static and dynamic ones. So a path is where it starts from a point A to go to a point B, which path it's going to go through. So it can have different paths or different routes. It's the same, or roads, whatever you call them. So it's just the way to go from A to B. That I don't know whether that's answering his question, but that's what it means. It just means the same, basically. But what you need to understand is that in a routing table, we don't call it path, we call it route. We say we go from route X to go route Y and so on. And it's the overall, it's
Chaque routeur fait le même exercice et à la
each
fin,
router is doing the same exercise, and at the end you will have one path. So that path will go through different router, and in each router you have a routing table, and in each routing table you have the outgoing interface. I don't know whether I've answered that question, but that's, let's say, the difference between a route and a path. Thank you very much, Kudia. I think Sylvain will be able to precise this question if he wants to, but often it's not very easy to use specific to translate terms into French when we're used to using them in English. I wanted also to precise and ask you at the end of your presentation, you said that nowadays the problem is that is the more present is that it's more technical, because there is a number of engineers that have been trained. But so from your experience, because this might bring us to why do we have problems with IXPs? Is it a question of awareness, or do you think there's something else that we can work on as a community? Because you've mentioned some organization and saying that we could do some more lobbying, but you as a trainer and as an operation engineer and also as a user, do you think there are things on which we could work? Thank you, JB, for that question. To conclude, yes, I was mentioning organizations like ISOC and others, because often in terms of reinforcing capacities, there is quite a lot has been done for reinforcing capacities, building capacities, but politicians, if they don't understand what's at stake, even though they are trained, and even if technicians are trained, we don't manage to convince them. Maybe we need to think of a curriculum that is dedicated to leaders, that doesn't have any technique, but just concrete example. For instance, a client, the student that is here and he's trying to reach to get some information online and cannot, and here they could really see where there is a lack and what can be done, and they would because sometimes they think, oh, that's enough for business to run as it should. And I think this is something that could be interesting. But you need the synergy of local actors, politicians, technicians needs to work together and try to see what the business model should be implemented to reassure at least the operators, because some don't understand and think that by the exchange point is here to, but there is no, then is the exchange point is not doing any transit, and I still pay for that, even though I'm doing BGP. It's not the IXP that is going to give me access to internet, and it's the provider that is giving me access to internet. And I think we need to show that better and explain it better so that they can understand what's happening, and also the development of local content, because we have local content that is actually outside our country, and so it's such a pity, because it's a waste, and I think we could have done that internally in our country. I think that's such a waste. So thank you very much, Kudia. You presented a tool to help us make our decision. You asked the participants to not hesitate to work with you and the entire team who is working on that to improve some data that might not be presented very well. Linked to, this year there has been quite a lot of perturbation, like issues with in Western Africa and also in Eastern Africa recently. What message do you want to give to the community so they can get some appropriation of different components, so that first of all we can contribute, but also, and I'm going to let's say, share internally how can we do so that this tool is helping most people, and that will allow us to have a better internet, as Kudia was saying in her last words, with a contribution from all the stakeholders. Thank you, JB, for that very interesting question. As you mentioned, there has been different events, undersea cables have had an issue, and that has had an impact on internet provision in different countries. And here in ISOC, we are analyzing those events, and there is a direct link with resilience. We have not incorporated yet the aspect of undersea cables. So there are elements of structural infrastructure. We mentioned that on the resiliency index, but the number of undersea cable is not mentioned yet. And I think this is something that could be brought to the table in the future, but that's still a project that is developing at the moment. And not only is it important to have many undersea cable that link the countries at different level, because if there might be a catastrophe at that level, but and break all those undersea cable, because there's a single point of failure. because there are different countries in South Africa, for instance. Around the country, there are different entry points from those undersea cables, so we see a certain redundancy for that country to avoid issues. And finally, or on top of that, what I want to say is that the solution to diminish or reduce how much we should trust those cables is peering, because the more peering we do, the more local the exchanges are, and the less you depend on those undersea cables. We've seen in certain countries when there were events that they managed to have working internet. Of course, everything wouldn't be, well, not everything was operational, but if e-governments had their services in locally and peering was happening as it should, their service shouldn't have been impacted. So peering can solve some of the problems, not all of them, of course, but part of them. We've seen as well that in certain cases where there is a specific ecosystem of peering, like in Kenya, for instance, where there are different CDNs that are there. We could imagine that because those CDNs are here locally, we could imagine there wouldn't be any problem when if there is damage to an undersea cable, for instance. But that's not really the case, because even those CDNs, they need those international accesses to be able to refill their cache. So sometimes those cache becomes unusable following those events, because even though if they have some data locally, it's good when it's working for the for the users, it's good, but when it doesn't work, it has an impact. And we've seen that recently during the event that happened a few days ago in Eastern Africa, where there was a reduction of traffic on the exchange point in Tanzania on the Akamai network, which is something we might not have thought of beforehand. So it's peering is important. Local services can be accessed locally, and it should be accessible to all networks. And then the more data centers there are, the more local content there will be, and the best it will be for the users locally. And the impact on internet when there would be cuts or damage on cables won't have as much impact.
Thank you very much, Amrish. We have got about 15 minutes left for our session. Thank you very much for all this information that you've shared. And from CUDIA, I'll remember that together we need to work all together to encourage for more peering, be it technical or non-technical. And we need to have presentations on economic aspects. We've had quite interesting presentations from Ghislain and Sylvain this morning. And I think we need to raise awareness with decision takers. Thank you, Amrish, for your presentation and for your concluding remarks. We can see here that we were trying to gradually help with decision making, but we need to be able to anticipate and improve resilience in different countries. So I think we might be able to stop here for today. The discussions will continue. I'm going to give the floor to Ghislain or Sylvain, who may be able to conclude the session for today. Ghislain, I think maybe you can take the floor. Thank you, everyone, and thank you for giving me the chance to moderate this session. Thank you, Jean-Baptiste. I think maybe Sylvain, if he's online, should take the floor. Sylvain, can you hear us? Very well. His mic is off. It's not a problem, it's fine. Thank you very much to all of you. Thank you to all our speakers and any person participating in the event. Thank you to all those who asked questions. Thank you to our interpreters for this fantastic first day where we were able to cover many topics. We can only hope that these actions that have been described as challenges will be overcome, and that we, in a relatively close future, will have developed ecosystems that will allow us to sediment the security and this protection of digital environments. Today, I was thinking about 2030, I think. Maybe not 2030. I can't remember. But the population of Africa will have doubled 2 billion, I think. So there's a lot of work to be done to prepare our continent. It's a dynamic continent, and it's full of young people who want to have work. So I think now is the time to build those infrastructures to prepare for that future. See you tomorrow, same times as today, so 10 Universal Time, 11 in GMT +1, and we will continue with our different sessions. We will have 3 sessions, just like today. We will have another keynote session. We will have a discussion on policies, governance, and regulation. And finally, we will have a lightning talk session with short presentations. I think those are generally quite interesting. Please share the event with other people, and there will also be recordings after the event. Thank you very much, and we will see all of you tomorrow.